Okay, before I talk about natural logs, attention up here, please. We're going to talk about natural logs. I need to talk about compound interest. Does anybody know what compound interest is? You have an idea? Hold on. Right idea, very good. So the idea and the compound interest is, say you have a CD that earns 5%, and usually interest is that's compounded is compounded monthly. So after the month, what happens is that they take whatever amount you have accrued on interest and they add it to your account. And then they say, okay, now you're going to get, next month, you're going to get interest on the original amount plus the interest. Does that make sense? So would that be more money when it's compound interest? Yeah, more, you know, so so that's a good thing. So it would seem like when we are doing that, what seems like if we keep compounding more often than once a month, seems like if we compounded like once every day, or once every hour, or once every second, that number would keep getting really, really big. But what ends up happening is it goes to this number that if we put it into this formula, let's see. As n approaches infinity, what we end up getting is it's going towards this number. And so it's this number that just keeps coming up in math. So it's similar to pi in that it's a number, but pi is much easier to explain to you because you understand a circle. You understand finding the area of a circle or circumference of a circle. Compound interest is something that's more complicated, and most of the applications that we have for compound, you know, for the E have to do with calculus. So we're going to talk about E today, and we're going to use it, but I'm sorry that I can't give you a better explanation for that because the better explanations are calculus based. Okay. So the number E is similar to pi in that it goes on forever, and it's a number, and it's constant approximately equal to 2.71828, and so it arises in the computation of compound interest. So it is actually a button on your calculator, and it is the button on your calculator. I write it in cursive just because it's easier. It's an LN. Okay, so if you look on your calculator, there's an LN. That is a natural log button. So it represents a log with a base of E. And yes, it starts with L, and even though we call it a natural log, it comes because it's a translation from another language, but it's also, we like that log first, L. It's like log natural. So you should, it's a lot of calculators have a capital LN instead of a lowercase ln, but when we write it down, it's in a lowercase ln. Okay, so what I want you to do is I want you to find it on your calculator, and I want you to find 2 through 5. I will talk about 6 with you. So go ahead and on your calculator, find the natural log of these numbers. So it is right below it, right to the next, to the right of LOG. Oh, that one.
Oh,
yeah,
it looks like an eye.
I know it does. Yeah, so it's Where's the log? It's right below the log key. Yep. Let's see. What you got? Yep. That's what you should get on the first one. Please help each other if you if people are having trouble finding it on their calculator. Yeah, 0.693. Yeah, so we're rounding to the nearest thousand. What's that? It is. It's a natural log, so it's just so it's right next to this one. It's ln. It doesn't say log e. It just says ln. Yeah, I know. Everyone's having a number of people are having trouble with it. Yeah. So we'll talk about it. That one's going to be hard. We're going to talk about number 6, but there's the answers to the others if you want to check. 6 is a little bit harder to figure out how to do. Okay, so if we're doing number 6, on your calculator, you're going to do natural log. So to find the e on the calculator, on say the blue calculators, you're going to do second, and then you're going to press this button again, which up above that, that's an e to the exponent. Okay, so you're going to press the ln key, then second, and then you're going to press that ln key again because it's up above. That's what second means. Now this, see how this is exponent here? It wants an exponent. So what is the exponent when it's just e? It's assumed to be a 1, so it wants a 1 there. So you have to put a 1 in there. That's better. What's that? Sure. Yeah. So you put a 1, and then press enter. Yeah, close it and press enter. You get 1. So why is it that we get 1 here? So what is the log of 10? Why is it 1? You're right. That's equal to 1. Listen to this, because we're going to use this today. We're going to use the log of e. So why is the log of 10 1? That's right. It's a base of 10. So 10 to the 1 is 10. So when we have the natural log of e, that has a base of e. So e to the 1 gives us e. So that's why the natural log of e is equal to 1. Does that make sense? So just like the log log, we don't usually write that base there. We leave it off because we know it's e. Okay, so now let's do some problems where we use it. Okay, so suppose we are solving for e to the n equals 89. So we want to find that exponent. Let's change this to an x so it's not confusing. Let's make this an x instead of an n. So e to some letter, some variable is 89. How do we get to that exponent? What is it that we have to do first? Yes, we have to take the log of both sides. So we have an e here. Which do you think would be faster if we do the natural log of both sides or the log log of both sides? Natural log is going to be faster. And I'll show you why. So we did that so that we could move that variable where? Where can we move the variable? the front. So this becomes x times the natural log of e. Well, what is the natural log of e? What did we just say it is? It's 1. So this would be the same thing as just x here, because x times 1 is x, right? So then on our calculator, we just need to find the natural log of 89 to do this problem. And what do we get? 4 point. Yep. Questions on that? If you have a question on where that LNE went to, ask me, because I know I've given you a lot of information here, a lot of new stuff. I'm happy to talk about it. If you decide you want to ask me later, that's fine. Okay, so what do we do first on number 8? Divide by 2. We've got to get this e to the m by itself first. So we're going to divide by 2. When we take 97.1 and divide it by 2, you get an exact number, 48.55. So we can do that. I'm not going to leave it as a fraction. So now what would be our next step? Yeah, either one. And you can do the LOG. They'll both work. You can do the LOG. It's just the LOG, you're going to have an extra step that you have to do. So it's easier if we just take the natural log of both sides. So now we're going to move the m to the front. And then we're going to find the natural log of 48.55, and that is 3.882. Does that make sense? Easy to forget to round. So you always want to look at that last decimal if the number to the right is 5 or above. Okay, what's our first step on number 9? Somebody in this group tell me what our first step would be on number 9? Yes, divide by 3. We've got to get that e to the k plus 8 by itself. And again, when we take 96 divided by 3, it is 32. So now we do what? Log e. That's right, log e, or natural log. So natural log of both sides. So we're going to move that k plus 8 to the front. And then natural log of e is just 1, so it's just equal to k plus 8. So our last step would be to, good luck, subtract 8. And when we do this on our calculator, do we put, the calculator puts a parentheses. Do we put a parentheses around 32 minus 8 or just the 32? Just the 32. See, this is a little different because your exponent had a number there that you did something with. So you're going to subtract 8 after you find the natural log of 32. Does that make sense? See the difference? And what do we get? What do we get, Nick? Good. Good. See how you took just a couple seconds there to think about it? It's easy to forget. I like that you took some time to think about whether you needed to round or not. Okay, what's the first step on number 10? In that group back there, what's our first step on number 10? Yes, good. We want to divide by that number in the front, divide by negative 1.8. We get e to the 5b is 30. And then, hey, Son, do you know what to do next? Yes, which log? The natural log or the log log? Good, good. It saves us a step. So then we move our 5b to the front. Oops. And then we divide by 5. Write it as another step. And then go ahead and do the U-try. Yes, good job. Good job with rounding too.